So my name is Peter Knight. I chair the UK National Quantum Technology Advisory Board for DCIT and also chair the Quantum Metrology Institute at NPL. If you think about the kind of coherent light that you're used to for lasers, they're all in the optical region, the sort of red laser pointers that everybody knows about. What we're interested in doing is building that kind of uniform, coherent wave, but at X-ray frequencies, and to do it at real efficiencies and to get the pulses of light coming at you with a really good repetition rate, so you can actually do some really great science and engineering with it. So what an XFEL is a delivery mechanism for really good coherent light in the X-ray region that could really start to probe matter at the atomic scale. Laser science in the UK is really powerful, and it's a great propellant of the economy, by the way. Photonics, which lasers is part of, generates more for the GDP of the UK than pharmaceuticals. So we've got an amazing industrial appetite to build on this and a tremendously vibrant research activity. I think if we were to have an XFEL and that community around it that starts to really work in an interdisciplinary way, there will be surprises. If I worked out what we would discover in a decade, and I guess now, I bet you I'm wrong. But what will it do? It will transform our ability to understand catalysis. Why should we worry about that? Think about the energy usage in catalysis. If we could do that, it could really transform us, and it would be a scientific breakthrough of extraordinary power. We've got a great deal of experience with X-ray lasers, using LCLS in Stanford and XFEL in Hamburg. But what about doing something in the UK where the enthusiasm for that next generation of people can really drive great science and great applications? The kind of things that we want to invest in really should be identified by whether this really does resonate with all of the really big technological concerns, the really global challenges we have. That could be net zero, for example. It could well be working out ways in which we improve our energy and our distribution of that energy appropriately. All of these things can be explored using an XFEL. And I think this is really important for us. It's an enabler. You're building the most wonderful microscope at the atomic level.